Hi, I'm Chris Herbison. I'm the lead developer at Dr. Block.
Yeah, and I'm Dan Siri. I'm the team lead here. Kind of put this thing together through some mutual friends.
Like, for people who don't know, give us a brief synopsis of what Starlight is all about. Oh, Starlight. I keep calling it Starlight. Straylight. That's my bad.
So Straylight, basically, so what Straylight's all about is you're flying through this virtual galactic universe. It's an obstacle course where you're just trying to get from point A to point B, and there's this omniscient being trying to prevent you from getting there. But it's really a training ground, so it's not malicious in that they're trying to prevent you. They're trying to make you better. So really, the point is to master your Straylight. So that's kind of how you're propelling yourself through this world. It is a simple mechanic, but it is definitely something that takes a lot to master. So yeah, that's pretty much Straylight in a nutshell. That's my elevator pitch.
How did the idea for this game come about? Like, what did you guys like? How did the prototype? Was this a game jam? A lot of these VR games sometimes are game jams.
Oh, absolutely. So we did participate in the 2018 Global Game Jam. The theme was transmission. So we had never made a VR game before. We had mostly made 2D games previously. So we met up at this game jam. We brought in some of our filmmaker friends to add a little different flair, different skill set. Up until that point, Chris and I had been making games. We're both software developers, programmers. So we brought in some art talent and filmmakers and musicians. 5 of us got together at the game jam, and basically we riffed off the idea of transmission, trying to connect different checkpoints to one another to unlock a final portal. And the initial kind of idea was that you had to like figure out how to unlock it, and then it evolved into, let's just get rid of that part and get to the heart of it. Like, you're just speed running through this universe, going from checkpoint to checkpoint, avoiding obstacles and getting to where you need to go.
Can you talk about some of the challenges? I mean, making a game has its own set of challenges, but when you're making a VR game, it's almost a completely new wave of challenges. Can you talk about some of the challenges your team faced while making and designing this game?
Sure. Yeah. Some of the challenges that we've run into with Straylight and being in VR, I will kick it over to Chris in a minute, but it definitely, the tooling was evolving underneath us. Like, as we were developing, updates would change how things work in VR. There's new headsets coming out constantly. The control schemes changed, like going from the Vive to Oculus to the Index Knuckles. We had to kind of keep up with the changing landscape of VR. And when you set out and make a game in 2018, by 2021, the whole landscape's different. The physical devices are different. But from like a software perspective, I'll kick it over to Chris, because that in and of itself was a challenge.
Sure, yeah. So I think a lot of the early challenges we faced were more around trying to get a good set of physics together that were comfortable and didn't kind of make you dizzy or nauseous while in there for perhaps long length times. Beyond that, like Dan said, with constantly new headsets coming out, we had to constantly revise what control schemes we were using, what buttons would do what on each controller, and just finding the most comfortable and intuitive way to have our controls laid out on each of these controllers.
Chris, can I share the story about when you trolled me in VR?
Sure, yeah.
So in the early days, we had some debug code to move the player around. People in VR do not want to be moved if they did not engage in that movement themselves. So that was definitely a nauseous experience. And I think from that day forward, our mission was to make a game that was comfortable and not nausea-inducing. So a lot of our design decisions, a lot of the challenges we had were, even if the player is moving their hand around a ton, how do we prevent that from translating directly into like jarring movement? Or with our murder objects that are trying to kill you in the game, they fade to red and you go back to your platform, you're back in a safe spot. So at any time, you're one button click away from being back to safety, and at no point do we move you around in any sort of jarring motion, and we try to keep the physics very smooth. We didn't take an out of the box solution with that. Chris and I kind of hand rolled the physics in Straylight to make it as smooth as possible.
Can you guys go into a little bit more about the physics? That had to have been like a vigorous process, constantly tweaking and adjusting. Is this too fast? Is this too slow? Are you falling down too quickly? Like, how did you fine tune it so it felt really good?
Yeah, there's a lot of parameters that we have in in our game. Chris, do you want to kind of talk about some of the things that you've gone through with damping the physics and creating the orbital kind of structure?
Yeah, so obviously, starting out in a game jam, we had a very rudimentary solution for physics. It was still custom rolled at that time, but it was, just basic math to figure out how to move the player forward when they connect to the nodes. As time went on, both for comfort and for just enjoyability in the game, we took constant revisions at this, some of which were massive to the degree where we needed to redesign some levels even, just to make them work with the new speeds, or again, dampening, smoothing out like movement curves as you let go of nodes or fling yourself to get a lot of speed. I think the secret sauce there is really just constantly reassessing and tweaking it to get it in a comfortable view. And as Dan kind of alluded to, early on, we set up some debug variables that we could tweak back and forth to at least get a pretty good feel for an adjustment of a lot of the different things that go on with movement in the game.
Yeah, and it was a dance between the level design and changing the physics, because if we made things go faster, then we had to kind of catch the player's movement with like maybe a more sweeping turn, and if we made it so you could launch yourself farther, then some of the jumps we had in there became trivial, so we had to make those larger gaps. But we also don't want to frustrate new players who are going from node to node kind of slow, so we had to kind of build that difficulty curve up, and introduce those jumps as slowly as we can. So it was constant back and forth, changing physics, changing levels, rinse repeat for over a year.
A lot of game developers do procedurally generated like levels or whatever have you, which has its own set of challenges. But in my personal opinion, I feel when you're handcrafting an experience where you have to design a level a specific way, that's a lot more work, because you have to make sure all of it works and they're each handcrafted. Nothing is like just kind of thrown in randomly. You have to have, and each one has to be diverse as well. Can you talk about the challenges when producing handcrafted levels?
Our level designer, Ben, takes painstaking effort to place every node, every object in the level, and Len, our 3D modeler, graphics guy, crafted these monuments in the middle. So there's like a showpiece in every level. And I don't know how Ben did it. It was just labor of love, making every level handcrafted. I offered to make tools. I did. I have a couple small tools and some guides that he can use to make the levels, like some reusable pieces, kind of put together like a little bit like Lego, but each thing is tweaked to make sure that that's perfect. So just a lot of time, a lot of energy, a lot of play testing as well.
Now there are, like you guys mentioned before, I think there are 4 current headsets on the market. You have Oculus, you have multiple different Oculus headsets, Oculus Quest, the Oculus Quest 2, PSVR, and the HTC Vive. How are you able to optimize for all the 4 platforms, and were any of those more difficult than others? Did you guys start with the PSVR and work your way up, or did you guys start with like something higher end and work your way down?
We started with the Vive. Chris and I both had a Vive. That's kind of where we started. That's what we had at the Game Jam. And then I got an Index when that came out, so we kind of went higher end. But then we really started getting the Quest build working, and that is that is what took the most time, because certain graphical features that are in the higher end systems weren't available there. But even that, like from the first Quest build I kicked out until the most recent one, it has evolved and gotten better and more optimal. So that's just crazy how fast this has changed, and the Quest 2 has added so much more as well. But yeah, shaving down triangles and verts in all of our levels, you wouldn't. But our game looks pretty simple. But if you don't optimize your geometry, it grinds to a halt on a lower powered device. So we definitely had to go through each level and optimize our graphics and lighting, specifically for the Quest. And because we did that work in the middle, not at the very end, we then moved on to the PlayStation VR and got a lot of those optimizations kind of out of the way for the PlayStation VR, and then just had to integrate with their APIs and things. But yeah, optimization was another labor of love. Like if Ben was making handcrafted levels, I was making handcrafted builds for all the different systems, and so is Chris with the PlayStation build. So yeah, that's been a journey.
From what I've been told, I mean, like the Oculus Quest and the Quest 2, as great as wireless self-enclosed VR is, it can be very frustrating for developers because you just don't have that power that you do on your PC to work with, and you have to render everything twice and get 60 frames or even more. I think it's 120 or something now. Isn't it 120 or still 60?
I think the Quest was still at 60.
Yeah, 60 in each eye. So you're rendering everything twice in double 60, and you have to do it on technically what's considered a mobile platform, which is even more brutal. So you get it running beautifully on your RTX 380, 390 at home. The second you try to port it to the Quest, you're getting 10 frames per second. You're like, damn it, that's a lot of work. It's a lot of work to get on that platform.
Yeah, no, you're exactly right. That was definitely a conversation with the visual guys. So how can we make this performant and still look good on the Quest?
Scale it down.
We're gonna have to kill some of our darlings here.
Can you guys talk about like obviously I love the color palette of your game, very like synth 80s. Was that like an inspiration when you guys were designing it?
Oh yeah, for sure. That kind of synthwave retro vibe. I wish Len was here to talk about that. He made a lot of those kind of retro design choices, and even the name Straylight comes from the Neuromancer book from the 80s. So there's like our game is steeped in kind of that 80s vibe. But yeah, we brought it into the modern world because it's VR, and yeah.
I mean, this game, there are certain games that can work in both, like VR and in normal game, but this is a game I don't think you could not do it in the regular design. It has to work. It only works in VR.
Yeah, this was ground up VR. Like we decided we were making a VR game, and we wanted, at the time, we didn't feel like there was comfortable movement in VR, and we wanted to make it so that you can move around and have fun and fling yourself around in VR, and have that old school like platformer feel and like difficulty curve, which was kind of hard to get if you were fighting the controls and fighting kind of the system to get there. So we really tried to smooth things out and make a game that was fun and fast, but also challenging, where you're not fighting the controls. So yeah, Straylight. I don't think Straylight just with a mouse and keyboard would be quite as fun. You have to be in there.
Did you guys ever entertain the idea? Because I'm probably not, but Nintendo has that terrible like VR cardboard thing you can slide in, and you got the Joy-Cons, so it's kind of like VR. Did you guys ever think if they could work on that platform at all?
We may have entertained it briefly, but we were targeting the higher end stuff, and then I was blown away when the Quest came out, because even though we lost all of the power of like a gaming PC, what we got was the total freedom. Because when we gave this to like my nieces and nephews were playing it and taking it to the first conventions while we were still allowed to do that, like kids were playing it and just like whipping around, just 360 grabbing nodes, and like they weren't worried, about tripping. the tethered version is still pretty good. You can move, you can move yourself around and look. You have, about a little more than 180 degrees to move around in. So we kind of designed it around not having to jump around 360. But when seeing people do that was really fun.
Oh yeah, I've seen the videos of people like turning rapidly in VR and pulling their PC off of their desk or unpopping it or breaking a cable. Yeah, you don't want to have people like have to turn around quickly in VR like 360 because unless you're on the Quest, you are tethered, so you have to be careful.
Yeah, you definitely want to like wrap the cable around something fixed and then duct tape it down if you're gonna give it to someone else.
Was there any obviously you're like you said, you're tethered and you have sensors for the HTC Vive and stuff like that. For the Quest, was there any challenge with the tracking, letting the Quest know where your hands were at any given time?
Yeah, absolutely. So in Straylight, any movement powers the Straylight. So that's another thing we did. Like instead of making it like you need to move from here to here, any movement gives you momentum, and if you stop moving, you stop moving. So so when you're on the Quest, if you like kind of wrap your hand behind your back, the headset can no longer see you. It handles it really well. It interpolates the movement and does something sane. But if you're trying to build up speed and you accidentally like put your hand behind you, you would just lose speed. It wouldn't do anything jarring. But that's definitely a challenge that I think we've solved. Keep your hands in front of you when you're on a Quest.
Yeah, that's been the one complaint I think I have about the platform, is that without the sensors, if you go out that 180 field of view, it's like, where are your hands? Where are the hands? And it doesn't know.
They're around. You need to throw a few in the back so that maybe you can see them if you go back there. But
surprised they don't have like little wireless sensors you can just put, like in the behind you or one behind you so it can track, I guess. But then it gets complicated after that, I guess,
Yeah, there's just something great about the grab and go with the Quest. It's just like, hey, draw your play area and you're in VR. Go nuts.
What was the greatest challenge from like a design and a programming perspective from this game for your team?
Yeah, Chris, I'll kick that one over to you. I mean, we've shared the programming load, but Chris was definitely lead programmer.
Sure, yeah. So I think probably the largest hurdle overall is debugging anything related to the physics. So because our physics, they're based on, relatively realistic physics, but at the same time, there are made up little fixes and things like that for, again, ease of play and comfort and things like that, that there's enough things in there that when things go wrong, it can be challenging to determine exactly what's happening. But yeah, I mean,
and reproducing like esoteric bugs.
Exactly. Like,
VR, with physics.
If I swing my hand just like this at this point while I'm moving at this vector, then I get flung this way for some reason or something like that. And again, our solution to that has been just building out our own tooling for debugging and figuring out, how we can get more information to ourselves about what's happening to figure out why it's doing what it's doing.
What engine did you guys build the game in?
Unity.
Was that any particular reason you chose that engine? Was it because of accessibility through all the platforms, or it did what you needed to do, or just what what Chris was proficient in, that kind of stuff?
Yeah, we started off at game jams, like we had written our own engines. We have used Monogame and XNA previously, and since we were doing a game jam and bringing new people on board, we wanted something that was accessible. And people at our local game jam actually went off to work at Unity, and they suggested, hey, you should use Unity. We weren't interested in 48 hours writing our own VR drivers and everything. So that's kind of where we started, and we stuck with Unity, and it's evolved with us. It's been good.
What have they provided in terms of support to help make this game a reality, if they did to provide any support?
Just constant updates, basically.
Yeah, I think that. Oh, sorry.
Go ahead,
yeah, I think the cross-platform aspect of it has helped us immensely as well. I mean, definitely to stress the work that we've put in to get things like the Quest build and the PSVR build working properly. But beyond that, it has been a cinch to kind of go across the various devices because of
Yeah.
the way the platform's set up.
Yeah, the build templates that they provide were very helpful. Like, you switch over to Quest, you're like, okay, I'm making an Android-based game now. You click the button, it re-imports everything, it rebuilds all your shaders and everything, and then a few minutes later, you're like, okay, I can throw this thing onto the Quest. And I think you had a similar experience with PlayStation VR as well.
Yep.
So that's one of the biggest benefits of using Unity, I think. I don't know if that's the only, if other platforms are also that easy, but it was that easy for us on Unity.
I'm told it plays nice with all the other platforms, so it's
Really?
it's not easy to port, but it's relatively straightforward if you're not writing your own custom engine, because I applaud you guys. That's really a lot of work, because when something goes wrong, or that you are the tech support, so you have to figure out how to overcome it yourself. So there's no forum or anything, because it's your own engine, right? You're the only guys who have access to it.
Yeah, we like tools now, and we like that our other friends and developers can jump in and contribute. With Unity and Unreal and other engines where you have that 3D interface. Someone who knows about 3D modeling is already familiar with how to move around, drop things in, modify things. So, we're not rewriting any engines anytime soon.
Chris, from a coding perspective or program perspective, you're obviously on a mobile platform, a PC, and a console. Were any of those particularly challenging to program for? I know like PlayStation has kind of a lengthy certification process sometimes, especially for VR.
So I think the nice thing again with the engine that we're using, it provided at least a consistent base for all of those platforms to work off of, which was familiar grounds to me. And then just filling in the gaps of trudging through documentation and figuring out specifically what I need to do on this platform versus the other one. Some have been more friendly than others, for sure. I think really where the big differences come down are the extra bells and whistles for things like leaderboards and achievements. That's really where there's a lot of split code for the different platforms.
Yeah, that's your netcode. That was the most important things that people the legacy developers Nintendo still has yet to figure that out. They do not know how to do netcode yet. It's incredible. It's one of the hardest parts about making a game. Even if it's just data of of timing and numbers, you still have to. Each platform has its unique way they want you to do it, and sometimes you're like, why?
Yep, exactly.
We've asked why a couple of times during this process.
Because I have to ask, when I immediately saw your gameplay trailer, I have to ask, was this originally a SpiderMan concept?
No, we never described it internally as SpiderMan, but we get that a lot. I think we just wanted to swing around in space. I've heard Tarzan and Spider-Man, kind of used to describe it. We really wanted to get away from the latch and then swing kind of mechanic, and kind of make something a little bit different. In our tutorial, we describe it as cracking a whip or twirling your hands. I've recently said that it's reeling in a rubber fishing line, because the more you move, the shorter your lead gets, but it's still made of rubber, so it'll kind of stretch and spin around. But yeah, no, we aren't looking for any trademark or copyright infringements with that.
No. No, for sure. Disney doesn't like when you get inspired by their things, ironically enough. So you guys can, where can people find more information about Straylight, and where can they go to buy it and support your endeavors?
Yeah, sure. So right now we have the demo and the early access version on Steam. So Straylight's coming out Q3 2021 on the Rift, the Quest, Quest 2, PlayStation VR, Valve Index, Vive, pretty much anything that's supported by Steam or the Quest, the Oculus Quest devices. So we'll be on Steam Store, Oculus Store, SideQuest App Lab, PlayStation VR, as I said. You can find us on Twitter at Dr_Block, Instagram at Dr. Block, and Facebook at Dr. Block Games. So that's where we're at. That's who we are.
That's awesome. And just because I'm curious, I need to know, did you guys get any? Is this all self-funded? You guys have a publisher? Is this all self-funded? Did you get any development money from Oculus or Vive or anything like that?
100% self-published, self-funded. We were in the Oculus Start program, so we did get some resources there. But yeah, it's pretty much all us. We're 5 developers from Cleveland that just kind of did it on our own.